Hello and welcome back. In this video we will be looking at one final example of a function and we want to find the derivatives, some derivatives of this function, and in particular they might not exist, so we'll just have to be a little bit careful. So right away I see that we have a some absolute values in here. So the way that absolute values work, so this is just a little aside. If I take the absolute value of x, we think that if x is positive, then if it's positive or in fact equal to 0, we just get x back, because the absolute value, we just make it positive. So if it's already positive, we don't do anything. If x were negative, we need to make it positive. And how do you make a negative number positive? By taking it times -1. We just add that negative sign. So the way this works is that if what's inside of the absolute value sign is positive, we leave it alone. If it's negative, we need to make it positive by adding an extra negative sign. So that's just a little aside. So for this guy, we need to work out what exactly is going on here. Well, if x, so if x minus 1 is positive, then what's inside the absolute value signs isn't going to change. It's just whatever it is. If it's positive, we don't need to make it positive. So this is going to be x minus 1 minus 2 if x minus 1 is a positive number. Likewise, if x minus 1 is negative, I need to make that negative. So I would need to make x minus 1. Maybe I could add some parentheses in there just to make it look nicer. If this is negative, I need to make it positive because I'm taking the absolute value of it. And then this minus 2 out here isn't affected. So that's if x minus 1 is less than 0. And what happens if we're right at 0? Well, you don't need to make, you don't need to make 0 positive or negative. It's just 0. So let's simplify these. So x minus 1 minus 2, well, that's x minus 3. And then if x minus 1 is greater than 0, well, if I add 1 to both sides, this is if x is greater than or equal to 1. And down here, I've got negative x minus 1 minus 2. Well, I've got a negative x. I'm subtracting, I've got a negative 1, so that's positive 1, minus 2, well, that's going to be this. And then this is if x is less than 1, if I move the 1 to the other side. So this is a little bit easier function to think about than having these absolute value signs in there. So let's find the derivative. So first thing first, to find the derivative, we need to find the difference quotient. And what you'll see is that we have two different parts to our function. Well, the two parts to our function are going to be very different. Over here we have positive x, so if we think about x minus 3, this looks like a line, a straight line with slope 1. If we look at this guy, this looks like it has a slope of -1 and just looks like a straight line, but its x is less than 1. So for the difference quotient, I'm going to find the difference quotient for both parts of this guy. So for x is greater than or equal to 1 first, will be this guy. So I need to take f of x plus h minus f of x all over h. So as long as x is greater than or equal to 1, we're just plugging it into this top guy. So this is going to be x plus h minus 3 minus x minus 3 all over h. So far I just have f of x plus h minus f of x. And what you'll notice is that I'm subtracting an x from there and there. And I have a minus 3. Maybe it'll just be easier if I write this out rather than skipping steps. Minus x plus 3 over h. we see that we have an x and a minus x. We've got a minus 3 and a plus 3. So what we're left with is just h divided by h, which is 1. And hey, that looks like the slope of this line, right? So this is good. So the difference quotient for x is greater than or equal to 1. It's right here. The difference quotient for x is less than 1. Again, we'll have a similar thing. So f of x plus h minus f of x all over h. If I plug in my x minus h into here, I'll get minus x plus h minus 1. So that's just plugging in an x plus h into there. Minus f of x, so I need to subtract my function and divide everything by h. We're going to see something very similar happen here. So up here I've had minus x minus h minus 1 minus a minus x minus a minus 1 all over h. So negative x and x cancel, negative 1 and 1 cancel. So I'm left with negative h over h, and that's going to be equal to negative 1, which again looks like the slope of this line. So our derivatives are working. So if I take the limit as h approaches 0 of my first difference quotient, I just get 1. And the limit as h approaches 0 of negative 1 is going to be equal to negative 1. Now we have to be a little bit careful here for the following reason. If I draw my function, what's going to happen? I've got x minus 3 for x greater than or equal to 1, and I've got negative x minus 1 for x is less than 1. So x minus 3 up, it's going to be there. So here is our function. And we can see that on the right hand side, our slope is always going to be 1. It's just going straight up. And is going to be equal to the slope. On the left hand side, our function is coming down, so we have a slope of negative 1. But right here, we have no slope. So when I look at the derivative at 0, we can see that our slope is just always equal to negative 1. And when I look at our derivative at 2, our slope is always equal to 1. Because this is just a straight line, and we can see that our slopes are staring us in the face right there. And we found that by using these guys. The question is, what about the slope at 1? Well, we can see that we have a corner in here, so our derivative is not going to exist. And another way to think about this is that both of these limits are happening right here. So right at 1, if I go 1 plus a hair and I go forward a little bit, my slope is going to be the slope of this red line here. But if I go 8x plus a hair, but I'm going backwards, if I'm adding a hair in the other direction, here's my slope, and it's pointing in the opposite direction. So the limit here doesn't exist because the limit. Let me just write this down, and then we'll finish up. The limit as h approaches 0 from the left of of f of x at 1 is going to be negative 1. Is negative 1. But the limit as h approaches 0 from the right at 1 is 1. The slope here is going to be 1 as we're coming in from the right, but negative 1 as we're coming in from the left. So the limit doesn't exist because the limit from the left and the right don't exist.